On, and some of you might say my videos are uncomplex, just boring, have the same theme, but I'm gonna do something different. I'm gonna vary my understanding of YouTube, and we're gonna do a reaction video. First, now we're gonna do a reaction video without that. Hi. You guys. You guys. Okay, I guess you're still there.
How to upload a video to
And my first reaction video is gonna be just don't. No, what? My first reaction is gonna be Alien Biosphere, my favorite series. And we're gonna start all from the beginning. Now we're only okay. Now a second. Okay, we got it. Now. Okay, so just so you know, guys, this reaction, yeah, we're only gonna react to part 1 to part 4, and then we're gonna stop.
When building a fictional world, one of the very first things to consider is what kind of animals, plants, and people are going to inhabit it.
Yeah, no. I haven't figured out any of that stuff. I've only gotten done with the basics of our planet and star with my alien biosphere series. If you haven't seen that, check it out. It's not very memorable, but I plan on doing something with it.
Are the life forms the same as or similar to those found on Earth, or are they entirely different?
Have we liked this video yet? Why have I not liked it yet? Every video, from now on, in the series, every video I come across, every video we watch, I'm gonna like, because I have no idea why I haven't liked it if this is my favorite series, because it just is.
The climate like? What kind of biomes and ecosystems are present? Depending on the type and style of the world you're building, the answers to these questions can vary dramatically. But for this series, we're starting totally from scratch. We are going to evolve a scientifically feasible alien biosphere using the principles of evolution. Of course, this will all be entirely speculative, since, so far, we only know of one instance of life occurring in the universe, but any alien life would be subjected to the same laws of nature as life on Earth. So by studying our own biosphere,
Okay.
we can make some predictions of what aliens might be like. But before we can make an
Right,
alien planet, we have to make, well, the alien planet.
Yes, I
As
get
in
that.
all the non-living stuff.
I was thinking it's cool for this room. And the pillow, because this might be a long one, considering the sheer size of some of these videos. These videos are long. I watched one to for I've watched 4 to 13 a million times, but at but at least this reaction this series is gonna be a little different because not too long ago, but not too recent, he made a 14th part about the mass extinction and the doom of basically all life on this planet.
We've got to lay out some groundwork about what this planet is like, since this will have a heavy impact on how its resident life forms will evolve. Now, planet building can be a huge rabbit hole in and of itself, and it's kind of out of my wheelhouse, which is why I've brought Artifexian along to help.
Hello!
So, where do we begin?
Best place is to start with a rough brief. What are you looking for?
Well, since I'm going to be evolving the biosphere from the very beginning of this planet's natural history, we might want to start out with something similar to the conditions of ancient Earth, but maybe tweak a few things to subtly influence the way life develops. Keeping in mind, of course...
Wait, wasn't there another guy who has done this? Yeah, there was another guy who reacted to alien biosphere. Okay, this is gonna be a rabbit hole of copyright, but no, it's actually not gonna be copyright. You should make it. Okay, this is. I haven't taken this into account that another guy has already done this. Wait, heads up. Humans traveling to this planet, the atmosphere will kill you faster than you losing your arm. The screen go down. So I get distracted. Turn off CC. Not turn on CC for your dum-dums.
that the further we stray from Earth-like conditions, the more complications are introduced, and the more speculative things we'll get when designing the biosphere. So we should probably err on the side of too Earth-like. Sound good?
Perfect, that's very doable. I already have a bunch of neat ideas, but first, let's start with your star. Or stars?
I think one star will suit our purposes just fine. Let's not get crazy. At least not yet.
Alright, one star it is. Let's set the star's luminosity to 75% that of the Sun. Doing so mimics the output of our Sun during the Archean Eon, 2.5 to 4 billion years ago. With the luminosity set, we can derive a number of stellar features, most notably
Does
your
the
star's
star have eyes?
habitable zone, the region around your star where liquid water can exist on the surface of a planet. No water, no life, so knowing this zone is really important. If we have your planet orbit at a distance of 0.85 AU, its average temperature will be about 20 degrees Celsius, which is hotter than Earth, but it's nothing crazy. This will also mean that its year will be roughly 298 Earth days long. Happy so far?
The video, I got a surprise for it. Yeah, it has to do with something with me making something in Spore.
Yep, that works for me.
With all that in the bag, we can move on to the planet itself. To construct your planet, we need to figure out its mass, radius, surface gravity, and density, all of which are related, like so.
Ooh, can we make it a low-gravity planet? I quite like the idea of working with megaflora and megafauna.
Definitely, we could keep your planet the same size as Earth, again nice and familiar, but drop the gravity to 80% Earth gravity.
Whoa.
Could we go lower?
Yeah, not really. Any lower in density would be such that your planet won't have an iron core. No iron core, no magnetic field, no life.
Alright then. 80% Earth gravity it is.
Okay, let's I need to check out the comments. Speculative biology time. 2 suns? No, let's get not crazy. Can we put hydrogen sulfide into 2 suns? No, let's not get crazy. Can we put hydrogen sulfide in the atmosphere? Yeah, this man said let's not get crazy. Let's go not get crazy. What? And then he put hydrogen sulfide in these poor creatures, and then he put hydrogen sulfide into the air that these poor creatures breathe. What the?
In terms of day length and axial tilt, we know that an Earth day was much shorter in the past, and that Earth's axial tilt varies over time. So, let's make your day about 20 hours long, and give your planet 22 degrees of axial tilt. This lower axial tilt means that overall your planet will be subject to slightly reduced seasonal variation. You okay with that?
Yep, as long as there's at least some seasonal variation, I'm happy. Now, what about the atmosphere?
I suggest emulating Earth's atmosphere as closely as possible. Messing with the atmosphere...
Our atmosphere is boring. I breathe. So you're telling me that I breathe 78% nitrogen? You're telling that me right now and you are breathing nitrogen, oxygen, and argon, whatever the freak argon is. I don't even know what one of the ingredients of air is, and I'm breathing it right now. I guess my body knows. So I don't even know what the ingredient of what I am inhaling is right now. Pretty sure argon's just one of those, just normal elements that you can just find anywhere. Get back to the
can
video.
be, well, messy.
Some might say interesting.
Oh boy, I don't like where this is going.
Me
I mean,
neither.
1.5 billion years ago, oxygen was super low and CO2 was super high. So riffing off that, I can do something
Carbon
like this.
dioxide?
But that's really not very...
Come on. Surely we can do something more interesting than that. How about we say 1% of the atmospheric composition is taken up by hydrogen sulfide?
You want to add hydrogen...
Okay, you're telling me that these poor... So you're telling me that now there's less argon in these poor creatures? What the... Why is there so much
Want to
nitrogen?
add hydrogen sulfide?
Sure. I mean, it exists in small quantities on Earth, including as a metabolic byproduct, and some organisms live off the stuff. So how about we just throw in a tiny bit extra, just to mix things up a little?
Like, okay, if you insist, but just be aware that the oxygen is below what is recommended for carbon-based humanoid life forms. The CO2 is far above what is recommended or safe. And the hydrogen sulfide, well, it's not recommended at all.
Don't worry, I totally got this. I think.
I mean, I hope so. Anyways, what's left? A moon?
Yes, let's just stay.
Hey, could you bring me food? Yes, here's a flaming rock. Okay. God dang it, Flamey's annoying. Wait, isn't it the name of somebody? Is it the name of... You know what? I'll figure out a good name for him. For now, I'm just calling him a walking fireball.
Stick with one moon for simplicity, and can we make it so that it creates fairly large tides?
Sure, one way of doing this is to place your moon close to your planet. Let's say it orbits about 50 Earth radii out, which will give it an orbital period of about 23 Earth days. Also, let's make your moon 50%
So
more
does
mass.
other people want to animate their creations? Just make a basic model, take your time, put it down, and then there. That's what the professional alien biosphere people do. Just make a model, put it down, and then You got a model that I can import into your videos. Get Campfire, maybe. For all those children dum-dums trying to copy the big boys, I'm gonna be a big boy when I learn how to use Blender. I don't even got Blender, but I will get it. That's why that's why there's been absolutely no talking discussion about my aliens biosphere because it's gonna be a rabbit hole of Blender. And I'm probably not gonna be able to make those videos very often, but I will be able to make animations when I learn Blender.
Than our moon. The increased mass and closeness will give you tides about 2.7 times greater than
Bony
those
shorts.
we experience on Earth. Now, obviously this will vary depending on local geography, nevertheless it is a good ballpark.
Looks great. And, speaking of local geography, I think the last thing I'll need is some land masses. Since I'm going to explore a big chunk of the planet.
What's happening? What's happening in there? I touched antimatter. He touched antimatter. And I also just why do you keep a pterodactyl in here? I don't know. That's Zion's pterodactyl. What? Why is the worst roommate ever? He's not even there. Oh, wait. I have wings. I merged with a pterodactyl. And I can't focus. What is with these cross-eyed googly eyes? I am a shade of purple. Purple. I have legs like a pterodactyl, and but my head's more God-centered like. I sure would be fine. Back
Planet's
to the video.
natural history, I'll need to know how the continents are going to drift over a period of a couple 100 million years or so. As we'll see, the shape of the land has a pretty huge effect on how life develops.
Sure, what are you thinking?
Well, I thought it would be cool to start off with a Pangea-like supercontinent, and then have it break apart into two continents,
Yup.
only for them to rejoin later.
Okay.
Sure.
And maybe an island continent could break off at some point as well.
Done. You happy with this timescale?
I'm starting to really get to my videos being extremely humorful because I'm starting to add more and more humor. If you have noticed, my videos been getting funnier and more quality, and been having more quality. First, it started as like one-in-a-mill baby YouTube channel, and then it turned into a proper channel with gaming videos and every type of video with lots of humor.
Yes, that looks perfect.
By the way,
Cool.
yes, I am aware of the fourth wall. So yes, I am fully aware that I'm a human in real life, but I pretend to be a xenomorph. Just don't tell anybody. I'm still a xenomorph to you. Still a xenomorph. But yes, I am fully aware of the fourth wall.
So there you go. A star, a planet.
There's literally nothing to stop me from breaking the fourth wall of theory. Maybe even I know if there's a fifth wall. And I was gonna tell you the truth. Just 14 breakable walls. And they get harder and harder to break as time goes on. And if you break all walls, you can travel through dimensions without having to use super technology or anything. I tried this with Stitch, and that's why he's able to appear in everywhere and everything. He broke the 14th wall.
A totally non-controversial atmosphere, and some land masses.
Excellent. Thanks very much for all your help, Artifexian. It's been a pleasure having you.
Get your
Not a
round,
problem.
stupid body out from my face. Next video. I don't really know why I'm skipping.
Last time,
What
Artifexian
if-
helped me create an alien
and what
planet,
if already
as
went-
well as its star,
did it for me
moon, orbital characteristics, atmosphere, and tectonics. Now that we know all the abiotic factors present on this planet, we can begin creating some life forms to inhabit it. There are many methods for going about doing this, but here we're going to start.
I don't plan on spoiling anything for you, so yeah, I don't plan on spoiling anything for you if you haven't seen the series yet. Or yes, I'm gonna start doing reaction videos.
Right at the beginning of the planet's history and evolve an entire biosphere. Of course, creating a fully fleshed out biosphere is a massive undertaking, so this will just serve.
So that just brought me back to this. There is a guy who's trying to make a holy Fred alien biosphere. All I have to do is search up spore. But realistic. And then these two videos are made by both the same creator, Candy Eggs. This is what I'm talking about. He's trying
If
to
you
make
sleep
a
on your
funny
side, I bet you hate your pillow, and this is why. They might be as fluffy as a cloud, but they just don't support your head, so you don't.
He is trying to make something like that. Back to the point of this video.
Last time, Artifexian helped me create.
Wait, what? Hey, I can breathe fire. It's blue. Wait, now I can change its color. I prefer regular fire. Orange fire it is. I'm starting to doubt if this will be fine. You can now breathe fire. So what should I tell you? Whoa, you look very different. I think you're a turnip. Turnip? I actually like that name. It suits me. Bye, turnip.
Create an alien planet, as well as its star, moon, orbital characteristics, atmosphere, and tectonics. Now that we know all the abiotic factors present on this planet, we can begin creating some life forms to inhabit it. There are many methods for going about doing this,
What was that?
but here.
Nothing. I wasn't talking to you. Now go back inside of your closet home. I literally built an entire space. I literally built a secret door which you have to pull. But you literally built a secret wall that you have to push to go into. Then you have your own living room, bathroom, TVs, guest room. Bye. Go. Wait, no, stop pushing me. I don't like to be. Problem dealt with.
We're going to start right at the beginning of the planet's history and evolve an entire biosphere.
Okay.
Of course, creating a fully fleshed out biosphere is a massive undertaking, so this will just serve as a pretty broad overview on how the principles of evolution can be used to design scientifically feasible alien life forms. So then, let's get to work.
Okay. Whoa, you never tried to 3D animate, unlike me.
After the planet consolidates and the oceans form, the world remains a fairly quiet place for quite a while. At some point within the first billion years of the planet's existence, life arises deep within the ocean. The exact mechanism of how life comes about is still not fully understood.
Yeah, it's not understood at all. Oh god, it's another horribly made game ad.
But as it proliferates, it begins to affect many aspects of the planet itself. In the history of Earth, the earliest organisms were most likely heterotrophic, meaning they were incapable of producing their own energy and thus had to take up nutrients from the environment. That is, they had to eat things. However, at some point,
That's why you and me eat stuff. Because it's essential.
very soon after life first appeared, an evolutionary innovation occurred in which some early groups of microbes evolved the ability to use inorganic molecules to power chemical processes from which they derived their energy. Organisms capable of doing this are called autotrophs, and include phototrophs, like plants and cyanobacteria, which use sunlight to power their metabolism, as well as chemotrophs, like extremophile bacteria that gain energy from geochemically produced sulfides. These autotrophic mechanisms seem to have arisen numerous times in unrelated lineages, so it's likely that autotrophy will evolve in some of the primitive microbes on our alien planet as well. Photosynthetic organisms may evolve to use sunlight to convert carbon dioxide and water into
Oh. Oh, come on, what, you blew a hole in the wall. Oh, come on. Oh, come on. Jesus. You broke my interdimensional collar. That cost insurance, Turnip. Go back. But, no. Look, he's gone.
sugars and
no more
oxygen,
turnip
but also,
interruptions.
thanks to the high proportion of hydrogen sulfide in the atmosphere, sulfur-oxidizing chemotrophs may thrive as well. Whereas on Earth, these chemotrophs are restricted to areas like geothermal vents, on our alien planet they may also flourish in surface waters. Additionally, hydrogen sulfide dissolves in water, which will cause the oceans to acidify, so these early life forms will likely have some means of tolerating the acid, much like acidophile bacteria on Earth. As these autotrophs
So you're telling me that that thing and whatever is being covered right there is, I know what is being covered, but that thing and that thing and that thing is more acid resistant, is more battery acid resistant than me. What type of nonsense is this?
proliferate, they'll start to change the composition of the atmosphere, as the phototrophs convert the carbon dioxide into oxygen, and the chemotrophs turn the hydrogen sulfide.
Oh, come on, Turnip. How did you even get out of the dungeon? You gave me this cute. What the fuck? Give me that back! No. Don't put me back! Don't put me back! I hate this. I hate the closet. You have your own. Did you even go in there? No, I didn't go in there. I didn't even go. My eyes are closed. What did the go check it out. Just stop pushing me. Stop. Why would you stop it? He's trapped in the dungeon now. No more interruptions.
Into elemental sulfur. And as atmospheric oxygen increases, it has a profound effect on the development of life. Oxygen is highly reactive, which makes it great for powering biochemistry. This results in the evolution of aerobic respiration, in some ways the counterpart of photosynthesis, taking in oxygen and releasing carbon dioxide. While other forms of respiration do exist, aerobic respiration is almost always the most efficient form. Once aerobic respiration evolves, we'll soon get complex colonial and eventually multicellular organisms, until eventually we come to a critical point in the planet's natural history. For most of its existence, life on Earth mainly comprised simple, soft-bodied creatures, with evolutionary changes taking place very gradually over vast stretches of time. But then, about 4 billion years into the Earth's lifetime, there was suddenly a huge burst of biodiversity called the Cambrian Explosion, wherein the ancestors of virtually every modern animal body plan appear in the fossil record.
Can you stop scratching against the door and take a look? How did I hear certain sound? My name. Doesn't matter. Oh, there's a pack of bananas this beginning.
Record, all within a span of only about 25 million years, which is pretty negligible in the timescale of natural history. While there were certainly many factors at play here, one element that may have contributed to this event was the evolution of predation.
Because sometimes it gets boring and there's not much reactions I can make, and this is a reaction video. There has to be reactions. So what is that? There's sometimes these videos get boring and I stop. There's not much reactions I can make to them, so I'm going to go take a break. It's just starting to get a little bit boring. Come back. I'll come back. Don't worry about it. done. Back to video.
Before this point, an organism could get away with just blindly floating about at the mercy of the ocean currents,
Yeah.
passively obtaining oxygen and nutrients from the
Yeah,
water.
very true.
There's no real need to deviate from this lifestyle, so there's no real pressure to evolve anything new. But with the advent of active predators, you're not going to last very long if you don't have some form of defense mechanism. This leads to the evolution of the first armor, the first defensive behaviors, and the first eyes. And this then puts an impetus on the predators to evolve some way around their prey's defenses, and this arms race then escalates, dramatically increasing the rate at which life diversifies. It's quite likely that the appearance of predators will trigger an analogue to the Cambrian explosion on our alien planet. So we'll say that around the 4 billion year mark, our previously simple, soft-bodied ecosystems will suddenly diversify into a huge number of new phyla. While difficult to define precisely, a phylum is a lineage of life forms in possession of a shared or related body plan. For example, insects, arachnids, myriapods, and crustaceans all belong to the phylum Arthropoda, meaning they all evolved from a single common ancestor whose body plan they adapted in various ways. So our first step is to design some basic body plans. These don't need to be perfect, or even necessarily representative of any one species. What we're looking for here is a rough blueprint that serves as an outline for our creature's anatomy and lifestyle.
Yeah, I can get that. That's... whoa.
What a sweet little orc village. Let's make some trees nearby, a few rivers, with a happy little bush over here. Perfect. And some cats. Everybody loves cats. What are you doing? My innocent cats? No! You will answer for it, dumb orcs. Well, let's start again. Create worlds full
What
of
the?
life.
While there's a lot of scope for variation, we can figure out what makes for a functional body plan by looking at some of the trends in phyla that exist on Earth. Let's compare a typical vertebrate body plan, like that of a dog, with a typical arthropod body plan, like that of an ant. Now,
I'll explain for you. So, even though they're different, so even though they look and are very different, they still got the same traits, just internally and outside.
superficially, these two animals may seem
Sometimes
quite different,
outside.
but they also show some pretty striking similarities. They both have a symmetrical body with limbs used for locomotion, a distinct head that contains a brain and bears the sensory organs and the mouth, and a body containing internal organ systems such as a heart that pumps oxygen-rich blood around the body, and a digestive tract that runs from one end of the animal to the other. All of these characteristics are especially remarkable considering the last common ancestor of these two animals looked something like this. This means that all of the above traits were evolved independently within these two body plans, suggesting that such characteristics readily arise in unrelated groups in response to similar evolutionary pressures, what's known as convergent evolution. And if these traits can evolve multiple times on Earth, then why not on an alien planet as well? Now, this doesn't mean that all body plans have to be built along these lines, but it recalls one of my personal world-building mottos: know the rules before you break the rules. In other words, make sure you understand why something is the way it is in the real world before changing it in a fictional world. So then, why is it beneficial to have these traits? To find out, let's create some sample body plans step by step and see what characteristics emerge.
Let's see what it
To
does.
start off, complex
see what these
multicellular
creatures
animals
turn
most often
into.
exhibit some form of symmetry. Some animals, like starfish, anemones, and jellyfish, exhibit radial symmetry, in which the body is arranged in a circle around a central axis.
Yeah.
While other animals, like mollusks, arthropods, and vertebrates, demonstrate bilateral symmetry, where the two sides of the body are mirror images of each other.
No, that.
Let's create two body
I'm a
plans,
mirror image.
one with radial symmetry and the other with bilateral symmetry. This already has some implications for these animals' biology. On Earth, most radially symmetrical creatures tend to be slow-moving, largely immobile, or sometimes completely sessile, while many animals that are bilaterally symmetrical display a high degree of mobility. Now, it could be that
What's that?
radiophyla on Earth just happened to have never
The model
evolved
I
to become
made
very
for
motile,
like,
or it could be that having bilateral symmetry is advantageous for a motile lifestyle. We'll touch more on this later, but for now, let's play it safe and make our radially symmetrical plan sessile, and our bilaterally symmetrical one motile. Sessile animals have the difficult task.
and also for a quick change of stuff, I'm probably gonna start getting busy on doing a secret project. I'm probably gonna start planning on a secret project now that I'm getting older and now that I'm understanding it starts with a C.
Task of acquiring oxygen and nutrients without moving, relying on the ocean currents to bring food and oxygen to them. These animals will typically have a surface through which they can absorb oxygen from the surrounding water, which may double as a means of catching plankton or other food particles. Obviously, the larger this surface is, the more food and oxygen the animal can obtain. However, if we enlarge the surface by simply scaling the creature up in size, we run into a problem. The larger something is, the greater its volume becomes relative to its surface area, which means that as our radial life form gets larger, the smaller its feeding surface becomes in proportion to its increasingly large body, lowering overall feeding efficiency. This relationship between surface area and volume is known as the square cube law, and it's a fundamental principle that has numerous ramifications for how life evolves. And keep it in mind because we're going to be referencing it a lot throughout this series.
Yeah, I know.
Our radial body plan will therefore need maximum surface area while minimizing volume.
Guys, I'm sorry that this is a reaction, but I'm gonna skip ahead a little.
Body plan will therefore need maximum surface area while minimizing volume. This favors a flat, leaf-like, or perhaps feather-like structure, much like sea pens and sea fans on Earth. And since this creature has radial symmetry, perhaps it has a circle of these structures in a flower-like arrangement.
Okay.
Meanwhile, our bilateral body plan presents a different set of parameters.
Here's one thing you need to do before buying anything online. Don't spend another dime on Amazon until you watch this first. Watch this. I can show you how to get the sweetest deals online when you shop from major retailers like Amazon and Target. You can drop prices automatically. I can show you how, but I can't do it for you. People are saving real money doing this. $160 million in the last year. Across thousands of different retailers, you'll immediately see this. See what I mean? You'll see better prices you had no idea existed. And you don't even have to ask. They just show up automatically. Download this free tool that'll give you access to the deals. Just click, click. Done. That's it. Simple. It takes all of 10 seconds, and there's no need to enter any personal information. There's no technical mumbo jumbo. It's that easy. What are you waiting for? It takes less than 30 seconds to start saving.
It will also need some method of gaining oxygen from the water, but if it's an active, motile animal, having a large feathery surface for gas exchange would increase drag, making swimming less efficient. This means its gills need to have maximum surface area, while also being hydrodynamically optimal. This may favor
Can you stop screaming in there?
for a long and thin body with gills running down the sides. One innovation that might come in handy here is segmentation, or serial repetition, the dividing of a body plan into a series of identical or near-identical units. Perhaps the most obvious real-world examples being arthropods and annelids, but technically, even vertebrates can be considered segmented, for reasons that we'll get into later. For now, let's say
we're not getting into that later, because our internal bodies, our spines are segmented, so we're technically segmented on the outside, and there's a couple more reasons that he's probably going to bring.
Bilaterian has 9 segments, with each segment possessing a pair of limbs and a gill surface. Perhaps it swims with back and forth strokes of its paddle-like limbs, which will have the added benefit of encouraging.
I can imagine it moving like swooshing, like just like curve your arms into the a mouth, like the mouth, and then open it, and then shoot it out, opening the mouth. That's basically how this thing moves, but with increased drag. Okay.
encouraging water over the gills and increasing oxygen intake. Being motile requires a lot more energy than being sessile, so this animal will need an efficient way of transporting this oxygen around the body, and this may come in the form of blood. Blood has evolved as a means of transporting oxygen and nutrients in many different animal groups on Earth, and comes in a variety of chemical variants. However, many blood-bearing animals don't contain blood in arteries and veins, but rather use what's called an open circulatory system, in which the internal organs are surrounded by a blood-filled cavity or hemocoel. This isn't quite as efficient as a closed circulatory system like those found in vertebrates and cephalopods, where the network of blood vessels creates a continuous supply of oxygen to all parts of the body. One way to make the system more efficient is to have a muscle or pump to ensure a constant flow of oxygen-rich blood over the organs, and of oxygen-depleted blood back to the gill surface. Perhaps our bilaterian has a series of muscular rings around the hemocoel, like a collection of primitive hearts, which will give the animal an efficient means of powering its metabolism. So that takes care of oxygen, but this creature will also need a means of acquiring food. Since this is a motile animal, it will be able to move to new areas to actively seek out food, allowing it to potentially adopt a predatory lifestyle. So it will need a mouth to consume prey, and a digestive tract to allow the nutrients from the ingested food to diffuse.
I imagine this. I mean, since it's the first round organism, I imagine this thing being the size of your finger. Which finger is this? Is this an index finger? Razor index fingers. That's probably this thing's length. That's probably this thing's
the blood
size.
and be transported around the body.
Size.
Now, since we're dealing with an active motile animal, and because it's bilaterally symmetrical, that necessarily means that the creature has a front and a back end. This pretty much inevitably leads to another very common evolutionary trend, cephalization, the clustering together of the nervous system into a head of sorts, which frequently co-occurs with the sensory organs and the mouth.
Look at that.
While cephalization does occur to a limited degree among radial body plans, it tends to be a lot more pronounced in bilateral creatures, for the simple reason that it helps to have the sensory organs arranged so that you can see what's in front of you, and to have a mouth near the sensory organs to make it easier to eat things, and so that you can sense the food before it's ingested. So first off, we're going to need to give our creature some form of sensory organ. In particular, eyes. Somewhat surprisingly, eyes seem to evolve quite easily, as evidenced by the fact that they've arisen independently many times across hugely disparate lineages, with even some microbes and seaweeds being able to sense light to some degree. What begins as a patch of light-sensitive cells...
Seaweed can sense light? How's that possible?
...may then form into a sort of cup that allows the animal to better sense the direction that light is coming from, and then a lens may evolve to focus the light directly onto the retina to resolve a clear image. Most often, animals will have at least 2 eyes, since having multiple eyes allows for increased depth perception. This can range from the only 2 eyes of vertebrates, to the 3 to 8 eyes of arthropods, to the 24 eyes of the box jellyfish, to the over 100 eyes of scallops.
I don't even like how that thing looks.
We'll give our bilaterian an array of 6 simple eyes surrounding the mouth, giving it a full view of what's in front of it. And once it has the ability to see, the animal...
Why did its mouth look like a butthole?
...will need a way of processing the sensory information. While nerves run the full length of the body, perhaps a ganglion or nerve cluster...
What? Okay, so there's the ganglion. At least I know that word. It runs into this. That's its brain.
...evolves near the eyes, like a primitive brain. And so now we have something like a head taking shape. Meanwhile, in radially symmetrical body plans, cephalization may involve grouping the nervous system around the center of mass, like the nerve net of a jellyfish or the nerve ring of a starfish. A sessile organism doesn't have very many intellectually demanding tasks to attend to, so it can afford to have a comparatively simple nervous system. However, if our radial creatures are feeding using a large, delicate membrane, that makes them very vulnerable to predators.
Cole, he's my miracle child. So how does your miracle child get cancer? How does that happen?
There was a mass.
So they may benefit from an early warning system. Perhaps they have vibration-sensitive cells or even simple
Right.
eyes near the tips of their feeding appendages
Simple eyes
that allow
near the
them to
tips.
detect incoming predators. But having the ability to sense predators does little good if there's no way to respond to it. Since swimming away isn't an option, many sessile animals have some form of armor for protection.
Yeah.
On Earth, the shells of these marine
Most
creatures
do.
are usually calcareous, most often calcium carbonate. But here, we have the opportunity to do something a little bit different. Remember that we've got an atmosphere rich in hydrogen sulfide, which dissolves in water, and we've got chemosynthetic microbes that convert atmospheric hydrogen sulfide into elemental sulfur. This means that there's an enormous amount of free sulfur available, so maybe the marine organisms can evolve to take up the sulfur to form hard shells made out of calcium sulfate. So our radial body plan can have a protective shell into which it can retract its feeding arms.
Okay.
Motile animals, on the other hand, have the advantage of swimming away to avoid predators, so our bilateral body plan may forego armor completely and instead invest purely in
So
speed.
what predators?
Now both of our body plans have a means of
These two, what predators? My man, what predators? What predators? What predators? These two things are literally the only two things that inhabit your planet. Man, I hate gods.
Respiration, feeding, and defense. But there's still one last essential detail to figure out. Reproduction.
Oh god.
The most basic means of reproduction is asexual reproduction, where an organism reproduces by essentially cloning itself, creating offspring that are, for all intents and purposes, genetically identical to the parent. Since doing this doesn't require a mate, the organism isn't limited in its spawning and can reproduce whenever it wants, allowing populations to multiply very quickly.
Okay.
However, despite these advantages, asexual reproduction isn't actually as common as you might think. There appears to be a strong evolutionary pressure across just about every branch of the tree of life to maximize genetic diversity, which allows for beneficial genes to spread quickly through populations and accelerates the rate of adaptation. Because of this, sexual reproduction has become the most common reproductive strategy across virtually every lineage of multicellular life.
Okay.
Even many kinds of bacteria have some mechanism for exchanging genes. Sexual reproduction most often involves a distinction between male and female sexes, but there's a huge number of possible variants on this system, and we'll discuss those at a later date. For now, let's say that both our radial and our bilateral body plans have individuals that are either male or female. When it comes to sexual reproduction, sessile organisms face a problem. How do you find a mate if you can't move? The most common solution to this is what's called broadcast spawning, where the animals release an enormous quantity of gametes, or sex cells, into the water. Only a tiny fraction of male and female cells will meet and develop into larvae, and only a small portion of those larvae will survive to adulthood.
Okay.
This is a very inefficient strategy, but it's one of the only reliable ways for sessile organisms to ensure a high degree of dispersal. Often, the larvae of these sessile creatures evolve adaptations to help them cope with this first incredibly vulnerable...
I recognize that. That's a plankton. Yes, the little tiny plankton from SpongeBob is a real animal.
Period of their life cycle. For our radial creatures, before the larvae have grown to the point where they can attach themselves to the seabed and develop their protective armor, they'll need to rely on some other defense mechanism. Perhaps they can adapt their underdeveloped feeding arms into appendages they can beat back and forth for locomotion, allowing them some degree of motility to escape predators and find a suitable spot to metamorphose into adults. For our bilateral creature, being motile allows it to actively search for a mate, which massively increases the chances of a successful fertilization. Let's give it a gonopore, or gland that produces gametes, on its final segment. And there we have it, 2 basic body plans. Depending on how detailed your project is, a full biosphere will have anywhere from half a dozen to over 100 body plans, but for this series, we'll just focus on these 2.
Long videos.
I'm going to dub the radial phylum Anthostoma, and the bilateral one Polypodia.
Okay, many
Note that I'm using standard Greek and Latin.
So Amphitoma, flower mouth, and then Polypodia. Polypodia, many feet.
Latin-based nomenclature, but feel free to use whatever naming schema makes sense for your project. Now, these body plans may not seem all that different from some of the ones that exist on Earth, but I've done this intentionally to demonstrate why certain real-world body plans have evolved the way they have. For your own project, feel free to run wild with ideas and create whatever off-the-wall body plans you
What
can
is
come up
that?
with, as long as
I
they
just
have a
looked up
justifiable
and I
means
saw
for
that
recreation,
freak of
feeding,
nature.
defense, and reproduction. However, remember that these body plans are just basic ancestral blueprints, and as they evolve over the next few 100 million years, they may become completely unrecognizable from these primitive.
Yeah, guys, that from the Cambrian age evolved into me, dogs, elephants, mooses, rhinos, alligators, snakes, turtles, birds, and everything else that's a vertebrate.
Primitive forebears.
Just
In the
backbones,
next episode,
basically.
we'll see how the descendants of these ancient creatures diversify into a whole menagerie of different forms.
Okay, thanks for watching, Artifixian. Okay, oh, special thanks to Artifixian, of course. But you can read the rest.
In the last episode, we covered the first 4 billion years of our alien planet's history, including the evolution of complex multicellular life and the resultant explosion of biodiversity from which emerged 2 body plans. As of yet, these body plans only serve as theoretical blueprints, but with the passing of millions of years, the various descendants of these ancestral forms may undergo heavy modification as they diversify into separate lineages, or
Now
clades.
see how they
A
evolve.
clade is a group of species that share a common
I
ancestor,
already noticed.
represented by a single
You
branch
might
of the tree of
already
life,
notice.
along with any and all branches that stem from it. For example, snakes form a clade of
Yeah.
reptiles, but also form part of a larger clade along with lizards, a group
Okay.
known as the squamates. And in turn, squamates can be grouped together with tuataras under the even larger clade Lepidosauria.
Okay.
However, lepidosaurs and turtles do not form a single clade because not all the descendants of the last common ancestor are included. This visual representation of the relatedness of different clades is
So
called the
crocodiles are the most
cladogram,
different
or
compared to
phylogenetic
them.
tree.
Those other
The
creatures.
next step in creating our alien
Okay,
biosphere
so
is to construct some
sometimes
cladograms for
I
our
don't
new body plans,
get it.
and to do that, we need to have them undergo diversification into different clades. This diversification is likely to be driven by adaptation to different modes of life,
Okay.
or, more specifically, to different niches. An ecological niche is essentially the
Okay.
role a given species plays
So
in
hold a
its
second,
ecosystem.
guys, because I need to analyze that chart that he gave us.
Reproduction, and its relationship to other species. Clades will often specialize for a group of related niches,
Bring it up
such as how
already.
the big cats have occupied the niches of large predators. However, a single niche cannot be occupied by more than one species within any given clades. This diversification
Okay. Okay, this is all to take in. I'm just gonna skip all the way back to down here. Blah, blah, whatever. I can't pronounce that word. Consumption, earthy, expansion, organic carbon, deep sea consumers. Physics, climate, mixing. Yeah, you can tilt your head to read that.
is
Oh, and it's the same word.
likely to be driven by adaptation to different modes of life, or, more specifically, to different
Let me
niches.
go back to where we were.
Cats have occupied the
Okay.
niches of large predators.
Yeah, I know.
However, a single niche cannot be occupied by more than one species within any given
Yeah, a
ecosystem,
single niche
or else
can
the
be
two
occupied
species
by
will be in
another.
direct competition, which would ultimately lead to one of them going extinct.
Yeah.
This will be important to bear in mind later on, but for now, we first need to identify the niches present in our ancient sea and see how our body plans can evolve to exploit them. To start with, the vast majority of energy input in almost all ecosystems will come from sunlight, which in our ancient oceans will power the metabolisms of billions of photosynthetic microbes.
Okay.
Specifically on this alien planet, though, there is another source of energy in the form of atmospheric hydrogen sulfide,
So remember
which,
I said before, yeah, this is starting to get a little out of hand. So this video is starting to get a little bit long. But first, before I see if I should end the video, gotta see how long we've been recording. We've been recording for only 1 minute. Wait. No, I read wrong. 1 hour 25. How? How is that? What? Yeah, I should probably end the video. Oh, but this was not without a big surprise. I'm gonna make one of Artifact's. I'm gonna make one of his creatures. Man, that was a big fart. Specifically gonna make the Polypodia, I think I pronounced it right. The multile ones, the ones that move, swim, whatever you think to call it. We're gonna be making those guys. Because I can prefer that clade over the other clade. This one do fine. Let's make a fin body. Make it a non-body. But first we have to find the mouth. I don't really think there's a lot of mouths that can simulate what we want. So for now, that will be our basic mouth. I don't know, so since it's segmented, I got this plan. Maybe we can do this. Make it look segmented. It's this thing is so cursed. Let's shrink that mouth. Maybe we should make the front piece bigger. Let's give it its dead, soulless black eyes with no thoughts. Give it its locomotion. On the fat bits, maybe you can rotate them after. Because you probably recall seeing Fig System flipped. Just the closest thing I got. I'm trying my best, guys. Part 2 will cover the next 2 episodes. How about we do 2 episodes? No, yeah, I like that. Yeah. Now time to flip it. Now it's starting to look like our dear friend the Polypodia. I think I remember how it was spelled. Polypodia. Have to give it its gray coloration. Oh, in case I ever want to animate this thing for some very odd reason, like test it out. Actually, I think we should test it out after this. No, it's if I want to do that for reasons. Where are the bones? Oh, this is the invisible bone radio. Just please make one. Let's see how it animates. Not how I imagined it to move. This is not how he probably imagined it to move. This thing needs to be higher up in the sky. I believe I can fly. What is an invisible bone femur? I don't want two. I want one. You idiots. You idiots. Ah! What the? Ah! Dang it. What I wanted to do is make it a little higher up. Fuse! For goodness sake! What is a bone humerus? Why does it go that way? Invisible bone radio. What is a bone cavule? What is a bone cavule? What is a bone chronic? Bone tapia. Jesus Christ, it can make a freaking human being. So we only need one. Give me one. It makes more ocean-like maneuvers. Why is this game so stupid? Fuse! 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 Maybe if I give it freaking feet, then fuse it. It still won't fuse. Get together. Stick fuse. I want one. That's all I want. I ask. That's all I ask. Is one. They got a polypodia. Okay, still not the animation I want, but it works. There's a polypodia bite. Oh god, that is so cursed. Like it has that. You know that, like when it freaking fused twins. You know that? This is what I'm witnessing right now. I'm listening to a fused twin. This thing has a fused twins. But yeah, just you know how sometimes a baby like people have faces and their faces are fused. That's it. I'm so done. Giving it all the abilities I want. And there is nothing stopping me. Hey, guys. Got it. Whatever. I got this thing. As a pet. I know what it is. There, now we can bite and charge the whole way. It doesn't have strong bite. Zero bites, and it determines how much bite it has. So I'm pretty sure this thing shouldn't have. Pretty sure this thing shouldn't have that string of bite. Bite one. Take 5 to get the full effect of this wing cutting. Sprint 5. And then just, sprint 3. Wait, is it mean, like cute? Mean or cute? Omnivore? Omnivore. Didn't even have a diet. So what was this thing before that? It was mouthless before that. I'm making it an omnivore. Can somebody make this thing speed? Speed 5. Jump. This thing cannot jump. It does not deserve the title of jumping. Sea monster headbutt. It's sea creature, so I'm giving it sea monster headbutt. And then there. Podpodia. All finished. Now let's test out my cursed creation. And I'll get a basic test dummy. Let's get an ocean. Because that's where this thing lives. And let's test out all its abilities on an mortal confused dummy. Let me make our dummy. AKA an immortal ball of absolutely nothing. It has to be sea ball, of course, so we're just gonna make a giant floating ball with absolutely no defenses. Just to make it even more basic, white, and it's nothing else. A white basic ball. Gonna name it dummy. Gonna name it test dummy. They got her it's a test dummy, not a task dummy. Idiot. Test dummy. Outfit. What is wrong with Spore? I was trying to make a simple adventure, and it decided that was a great time to crash. We really love Spore. We hate Spore. Don't tell me about test dummy was freaking lost. Skip this too. Skip. I don't care. Skip. Oh, hey, it's the Venice, which is oddly coincidentally right next to my dad's planet. Darth Prime is the creature, and Darth is the. Get a water planet. Put down our beautiful Podopodia. Take out the animal version of the test dummy. Make it immortal, have 0 speed, 0 detection, and make it this. Place it down. Take us, place it in front of it. it has a help for free. We can test on it now. It's okay. Since we have free attacks, we're gonna need free test dummies. I think we have to swim up to it first. This thing is super weak. Whoa! Now we know what Sea Monster Headbutt does. Bite it. Bite it, you little derp. We have a bite force of 1. This was this thing's strange ability to fly. Can this thing even jump? We can't jump. Whoa. Okay. Let's test out our recharge. Use our Sea Monster Headbutt to engulf it. There, guys, I made a video. We made a podopodia. Very simple. We killed 3 innocent test dummies. We killed 3 innocent, worthless test dummies, which are literally giant balls with no anatomy and no organs and are plain white. Fire Xeno, out. Your mama's almost as fat as the sea monster.